Hi guys, this sheet talks about domain and range, so let's talk about it for a minute, okay? So we learned earlier that the relation is any ordered set of x and y, right? And a special type of relation is called a function, and that it is special because every x has exactly one y, okay? So we know all that. This first paragraph just says that in more words than what I just said. So when we study functions, it's important to be able to identify the potential input, which is your x's, or also called the domain, okay? And the potential output, which is your y's, and your y's are your range. So let's look at example 1. It says find the domain of the following function. So that means, let me switch my little pins, that we're looking for our x's, okay? So I'm going to draw me a little arrow over here. When we talk about our domain and we try to answer the question like we're going to do here, we always denote our domain with the capital D. So we're going to say our domain is, and we look at our x's, which are always our first. We can see that in our ordered pair. So our domain is going to be 2, 3, 4, 5, and 6. Still not much better at writing on this tablet. Hopefully I'll get there. So once again, as it stated up here, these are our inputs. Okay. Now, if it would have asked for also our range, we would have looked at our y's, which would have been 10, 10, 20, 30, and 40. And again, it's okay for our y's to repeat, just not our x's. Okay. So this little paragraph down here says a graph of a function can always help to identify the domain of a range. So when we are looking at the graph, we want to always read our graph from left to right, right? We know that. I may have already said that. So once again, our capital D denotes our domain. That's supposed to be an equals. Let's go back. I did something wrong. My little finger wrote on that. Let's get rid of that. When did that happen? My goodness, 7 years ago. Okay, so D denotes domain. Our domain is always our x's. This is always how wide our function is on a graph, okay? And we always, when we go to write down how our graph looks, our function looks on the graph, we always write it left to right. That's our domain. Now when we deal with our range, we denote range by a capital R, and that's range. These, once again, are our y's, and our range tells us how tall our function is on the graph. And when we write this, we always write it bottom to top. Okay, bottom to top. Now this paragraph also speaks of interval notation, and it's kind of easy sometimes to get twisted up. Do you use parentheses? Do you use brackets? So let's talk about that. When to use parentheses. So you use parentheses when you have strictly less than or greater than. Okay, that's when you use parentheses, when you have the less than or greater than symbol. I always remember this. You use the rounded ones when there's no line underneath. You also use the rounded ones when it's negative infinity or positive infinity. Okay, because you can never get there. Like it goes on forever, so you cannot attain it. So that's when you use the parentheses. Now you use the brackets when it's less than or equal to or greater than or equal to. Okay, so if your inequality symbol has a line underneath it, you use the grouping symbol with the line. Okay, that's how I remembered it when I was in college algebra. I have really silly ways of remembering things. I'll pass those on to you. You can completely ignore them if you want to, or you can use them to help you remember things as well. Okay, like I said, my ways are usually pretty silly ways, but they worked for me, so I'll just share them with you. Okay, so this is everything on this page. Give me just a second and we'll move to the next. Okay, here's a function on a graph like I was speaking of on the last page. Again, I want to write up here that we always read left to right. Okay, so read sorry if you can't read cursive. I'll try not to do that. I fall back into that. I'm old. Sorry. So now we're going to find our domain. D, capital D denotes domain. So we're going to start, remember we read left to right. So we're going to start over here to our left. We're going to go across. The first place we see is this -3, but it has an open circle. Open circle always denotes a parenthesis. So that's the first thing we're going to do. We're going to say parenthesis. That is a -3, so we're going to put -3. Okay? Now, we go on across here, and the next place that we see that it stops is at 1, but this is a closed circle. I should have put that over on that other page, huh? Closed circle is the same thing as less than or equal to. So now we're going to put our +1, and that's going to be a bracket. I'm sorry I didn't put that on the other page. Okay, so that's our domain, right? Now we want to find also our range. So capital R denotes our range. Remember, our range tells how tall it is, but we always start at the lower one, right? Bottom to top. So our bottom, our range is always our Y, so it starts at a, you guessed it, -4, if I can speak right. But it's a filled in circle, so it's going to be a bracket. -4. Now, if we see how tall it goes all the way up. You guessed it. X equals 0. And if we go over here and look, our circle is open. So that is going to be 0. But open circle, you're right, parenthesis. Okay? So remember, this one was left to right. This one is bottom. I gotta put my top down here. Bottom to top, okay? And you can see that here, I just kind of like wanted to talk it through with you guys so you could see what was going on. Okay, I'm going to have to exit drawing to scroll up, so just bear with me for a minute. Let's see if I could do this gracefully. Right on. Okay, this one here, I should say this one, it wants the domain and range of this equation. So it says find the domain in the domain of the function. Well, if we look at this function, let's talk about it. It is a polynomial. The reason that is we have x squared. There is no x term, so that would be like plus 0 times x, right? And then this one has just a constant. So it steps down, which would mean it is descending. So this is a polynomial. Any polynomial that you ever run into in your whole entire life, the domain for it is always all real numbers, okay? So we know this. This guy is a poly. I'm lazy, so instead of writing polynomial, I'm going to write poly, okay? Like he's my friend. Give him a nickname. And polynomials are always, oh, there I go again, sorry. All real numbers, and this is the fancy symbol for all real numbers. I'm going to tell you now, most mathematicians are lazy. I definitely fall into that category. So if I could not write all real numbers and do a fancy symbol, I'm going to do that, okay? But instead of writing that, the correct way to do it is to say, like if you were going to put your answer in to like for somebody else to read, and then you would just say D, like domain equals parenthesis, right? Because you can't get to negative infinity to positive infinity. And I don't know how you make infinity signs. Those should touch, but this is wonky writing on a pad. I'm so sorry. Some people make their infinities like sideways 8s, but I can't do that. I really suck at making sideways 8s, so I usually do mine like this, and they usually touch. That's how I make my infinities. So either way, these are infinity. Ooh, oh, stop. Sorry, I do the craziest things on here, guys. I don't mean to. Okay, Oh, that's not what I meant to do either. We're going to get this right. Hang on, just bear with me. Sorry, it's early in the morning and I just found that funny. Jesus, give me strength. Okay, here we go. Last time, I promise. I don't know what I'm doing. Man, I'm going to try not to touch it this time. Which makes my handwriting even worse. Okay, so infinity could equal either one of these, right? I'm going to put a negative on this one so you guys know what I mean. Sorry. Ooh, sidebar. Okay, so I'm going to exit out of drawing because that was hideous. And I'm going to go down another page. All right. I'm sorry, guys. That's, man, amateur hour. Okay, here we go. Now we're where we want to be. So this wants to talk about the restrictions of domain and domain functions. So here it just wants you to figure out without a calculator what all these would be. I think this is a pretty easy thing for us all to do. Anything divided by 0, well, you guessed it. I'm not going to touch this because I'm scared of what will happen. Oh my gosh. I did not even touch it that time. I'm going to push pause and figure all this out. Okay. I think we're good now. All right. Anything divided by 0 is always 0, right? So here we go. We're going to try this again. I'm scared to touch it. And I make my zeros with a line through it. I don't know why. I've done that since I was very small. It's a very hard habit to break. So, yeah, that's my 0, okay? Well, 0 divided by 0 is also 0. 0 divided by anything is, yeah, you guessed it, 0. What's the square root of 4? Yep, 2. See, how does that? I'm sorry, y'all. As I stated, the square root of 4 is 2. Oh my gosh. Okay, 2. Now, this is the square root of -4, right? And you cannot have a negative under an even root, or that kicks you into the imaginary land, right? Imaginary numbers, and that's a place where we don't want to go. So this is going to give us 2i, right? Because if we pull out an I and then we take the square root of 4, it gives us 2i. So I'm really hoping this is going to write 2i. Yeah, we're winning. Now, cubed root of 8. That's asking what base do we multiply by itself 3 times to get 8? Well, that would be 2. And then once again, now we have, what's the cubed root of -8? Well, that would be -2. And why that isn't 2i is because this is a cube, which is odd. So the imaginary numbers don't apply, okay? So clearly describe the 2 trouble spots which prevent expressions from representing real numbers. So the 2 that keep it from representing real numbers is going to be the 0 in the denominator, excuse me, and then also the negative underneath the even root. So that would be your 2 answers here. I'm going to try to write them. Yes. I'm just going to say D-E-N-O-N denominator for shorthand since this is working so well with me. And then negative. Oh my gosh. Under an even root. My goodness gracious. I'm so sorry, you guys. This is frustrating me, so I know it's frustrating you guys. I'm so sorry. root. Okay, there we go. It'd be done if it hadn't been for this crazy Zoom thing. Okay, so the first one here we have, this is a rational or a fraction, right? So we have x plus 3 in the denominator. So when we have a fractional, the first thing that we're going to do is we're going to take the denominator, set it not equal to 0, and solve. So I'm going to do this over here to this side. So we're going to have x plus 3. We set that not equal to 0. I don't know what to do besides laugh about it, y'all. Not equal to 0. And then we solve for x. Okay, so to do that, we're going to move this 3 over. Okay, when we do that, it's a positive 3, so we're going to subtract 3 on both sides. So x, sweet Marie. If you guys know why this is happening, like, send me an email, okay? Please. susans.sullins@uaccb.edu. Okay, here we go again. I'm so sorry. Like, I for real do not know what. We're just going to leave this size. X cannot equal negative 3. So if it's a negative 3, like negative 3 plus positive 3 gives you a 0. So I really need to go back down in size. So it can't be a negative 3, right? We're going to assume it's all real numbers except this negative 3. So we need to put it on a number line, but I don't have enough space. Come on, bro. So if we were to put this on a number line, and we assume it's either anywhere from negative infinity to positive infinity, but the only number it can't be is this negative 3, right? It cannot be negative 3. It can be anywhere. I wonder if I could do a different color. Yeah, baby. It could be anywhere in here. And it could be anywhere in here, right? But it absolutely cannot be negative 3, right? So we're going to start at where? Because we always go from left to right. So I'm just going to write it in pink so you guys can see it. So we're going to start parenthesis because we can't ever attain this. So we're going to start at negative infinity. And we're going to go all the way up to, you guessed it, negative 3. But we can't include negative 3, so we have to put a parenthesis. Now, but we have to jump negative 3, right? Because we can't touch him. And in math, when we make a jump, we denote that by a union. So there's this fancy U that we use, right? It's like kind of like a horseshoe. So this says that we jumped negative 3. But we're going to pick back up on the other side of negative 3 without touching him. So another parenthesis, negative 3. And then we go all the way to, you guessed it, positive infinity. So this is our domain for here. Not much space to write all that, right? But that is our domain from there. So this guy goes here. Cool. Sorry for all the in, out, in, out, in, out. But that is our domain for that guy right there. Okay. Now I'm going to exit my drawing so I can do the second one. And maybe we're going to stay small for this one. I am so hopeful that that is going to happen. Okay, now we're going to do black again because we're going to look at this guy. He is under an even root. So whenever, we're always going to assume all real numbers because that's just what we do. And then we look at this. This is our second restriction, is if we have something under an even root, which we do. We have x plus 7. So when that happens, we take this x plus 7 is called our radicand, right? Because he lives underneath the radical. So we take x plus 7. Oh, please stay small. We just take the radicand, just the x plus 7. And then we set that greater than or equal to 0. Why we do that is because we know we can't have anything negative underneath the even root, right? We learned that up here because that kicks us into the imaginary, right? So now all we do, solve for x. We move the man who stands alone, right, separated by the plus or minus. He's already plus. We move him by subtracting him. Oh gosh, here we go again. I thought we were past it. Come on, buddy. Do what I want you to do. What we do to one side, we have to do to the other. Okay. So this is going to say x is greater than or equal to negative 7. I usually take my 7s, but I'm afraid it's going to make it bigger. So I'm not going to do that. It looks crazy to me, but I'm not doing it. So now let's put it back on the number line again. All right, here's our number line. Now we have negative 7. When your x is on the left-hand side and you have an inequality, you could always use that inequality like an arrow. That way you know which way your x is going. So our x is going this way, so we know that x is going to be bigger than negative 7. So when we write our domain, it's going to be d. But this is an inequality that has a line underneath it, so d is going to equal bracket negative 7, comma, infinity. Cool? And we can't get to infinity, so that's why that is. So this is our domain for this guy. Almost done. This again is the same thing as this one. This is the same thing as this guy, right? We just take the denominator, set him not equal to 0, and factor. Okay? X squared minus 7x plus 10. Factors of 10, same side, same sign that add to be 7. Well, what would that be? 5 and 2, right? Okay, I'm going to let you guys have it. I don't think I'm going to exit this drawing. And I don't think there's anything on this one. Nope, you guys are good. Have a great day. Sorry for the in and out. I'm going to try to figure that one out before I do my next video, okay? Have a blessed day.